Don't leave the meeting. Good morning, all. See, sorry for the inconvenience. Actually, there was some issue with the mic of my other PC, so I started it from some other PC. So just wait, let me set the path and everything for this now. So today we will start with the suspension system. I hope your automobile paper was fine. Was there any issue with the automobile question paper, automobile engineering question paper? सर कोई इश्यू था क्या ऑटोमोबाइल क्वेश्चन पेपर में? Say yes, no, whatever you feel. Okay, chalo. So I'll share the screen with you. Just a moment. So today we are going to discuss the presentation, or you can say the basic presentation on the suspension system. So when we The suspension system is the most, you can say, important part of the vehicle. And all of us know that when we go for purchasing of the vehicle, then we say that the suspension system of this vehicle is good, that vehicle is good, and so on and so forth. But what exactly the design parameter as a mechanical engineer we need to look into, so that we have to discuss today. So first thing, the why you require the suspension system is the suspension system of an automobile is one which separates the wheel or axle assembly from the body. Okay, so there is a clear cut two parts of the body. One is the wheel and axle system and the vehicle body. The primary function of the system is to isolate vehicle structure from shocks and vibration due to road irregularities. So please understand that the here it says that the primary structure, the primary function of the suspension system is to isolate vehicle structure. So this is the, you can say, keyword vehicle structure from shocks and vibration due to road irregularities. You know that when the vehicle is moving on the plain road, the vibrations they are least, and very less vibrations they reach to the passenger. And when you are driving on rough road, then in that case you have experienced that what is going to happen. So the end result is, if you the driver and co-driver, they both get fatigue if the road is bad and the suspension system is bad. That means all the road shocks will be irregularities will be transmitted to the passenger of the vehicle and the driver as such. So broadly, the suspension system consists of a spring, dampers, shock absorber, spring shackle, axle, wheels, and stabilizer. So in this chapter, we are going to study the complete arrangement of the suspension system, types of the suspension system, advantages and disadvantages of the suspension system. So the suspension system of a motor vehicle is divided into front end suspension and rear end suspension. Okay, please understand that this suspension system, it will be there even if the vehicle is, you can say, driven by electric motor and battery. Okay, so suspension system is going to be the part of the vehicle, whether the powertrain is based on the electrical system or it is based on the internal combustion system. So there is some standard definition that whenever you design the suspension system of any particular vehicle, then the two terms are there. One is the sprung weight. This weight refers to the weight carried by the spring, which includes the chassis and all components attached to the chassis. So that is called as the sprung weight. So here I have drawn rather, I am showing you the model, the spring and damper model. Have you studied this spring and damper model by chance in the vibrations? सर वाइब्रेशन में पढ़ा है क्या आपने? Spring and mass system. Okay, so you know what is the purpose of this shock absorber? What it does actually? The dampers, they are called as the shock absorber. So what exactly the damper is doing there in spring mass system? Reduce number of back and forth motion means what, sir? Exactly, you please reduces the vibrations means what? Vibration reduce होना means क्या होना है? तो उसकी एम्पलीट्यूड रिड्यूस होना है, फ्रीक्वेंसी रिड्यूस होना है, या what exactly you are trying to figure out here? Yeah, force transmission is going to be less, so amplitude is going to become less. So if the amplitude is reduced, so what is going to happen? What you achieve by reducing the amplitude? See what you achieve by reducing the amplitude, and amplitude of what? Sir, please answer. आपने vibration पढ़ा है. If you reduce the amplitude, what is going to happen? Most of you have given the answer that you reduce the amplitude. Suppose you reduce the amplitude, means what is going to happen? No idea? To reduce amplitude to zero with no vibration. That is correct, Saurabh, but means what? एम्पलीट्यूड रिड्यूस करने का फाइनल एंड रिजल्ट क्या है? यू आर रिड्यूसिंग द एनर्जी, यू आर डिसिपेटिंग द एनर्जी. व्हाई दिस इज एनर्जी डिसिपेशन? दैट इज द मोस्ट इंपॉर्टेंट थिंग. सो एनर्जी due to sudden shock, whatever energy is generated, a spike in the energy, then that you are trying to dissipate it by using the damper or shock absorber. So please keep this thing in mind. The final answer should be given properly. Okay, because since you have done course on the vibration, I have asked you this particular question. You have done it in theory of machines too as well. I don't know. So the unsprung weight refers to the weight that is not supported by the spring. So which includes the weight of suspension system. So please note that our suspension system, whatever we are discussing, refers to this unsprung weight. So unsprung weight is the wheel, axle and system, refers to the weight that is not supported by the spring, which includes the weight of the suspension system. So whenever you design the automotive suspension system, it has to be divided into two parts, and then the spring mass model is used to find out where the resonance is going to happen, where the, you can say, the amplitude is going to be maximum, and accordingly you need to design the components for the automobile system. Now before designing of the suspension system, we need to know what are the different types of the motions which can be possible for the vehicle. The first one is bouncing. So bouncing is up and down motion of the vehicle. Then rolling is basically motion about the longitudinal axis. That means if you draw the axis which is perpendicular, let us say that this is the axis. I am showing you the back end of the arrow. So the axis is going inside the vehicle. So with this you have studied in, I think, physics, electromagnetics and other, for showing the direction of the electromagnetics and other fields. So similarly here I am showing you the back portion of the arrow. The arrow is pointing inwards. The motion about this particular axis is called as the rolling. So either this way or the other way around. Now pitching is the motion about the axis which is perpendicular to the vehicle body. That means on this side face of the vehicle. So pitching is rolls about the transverse axis, and yawing is the rolling about the vertical axis. Here in this particular figure, all the three axes they are shown. So pitching, rolling, then you can say the yawing. These are the three motions we need to tackle with the help of the suspension system. Okay, so that way designing of the suspension system is not, you can say, that easy, because you need to know the vehicle dynamics completely. What are the forces which are acting on the vehicle and which force is dominant in which particular condition, and based on that you need to counter that particular force with the help of the suspension system. So suspension system usually is directly when the vehicle, when the customer is going to purchase the vehicle, he will take a ride and he will feel, and there are no particular parameters which can distinguish between the, or there is no particular parameter which will say that if this value of the parameter is more, your suspension system is good, and if this value is less, then your suspension system is not good. So you won't require a very soft suspension system. At the same time, you won't require, or you won't design any suspension system which is hard. Hard meaning, if you take the ride in a vehicle, you should not get the direct feel of the road. Because if you are getting the direct feel of the road, then it is basically the rigid suspension system and transmitting all the road irregularities to the passenger, which is going to increase the discomfort during the travel. Okay, so that way, and if it is a very soft suspension system, then the problem is there are chances that the vibrations will be more, the amplitude of the vibration will be more. So soft and both, it is not required. Usually if you ask the layman, so what will be his answer कि suspension system कैसा चाहिए vehicle का? Suppose you are a designer, and what is your ultimate aim of the suspension system? Means how do you define it in one sentence? Sir, if you want to give the input to the designer of the suspension system, what is that one word you may think that the suspension system of vehicle should be like this? Can you figure out, or can you tell me that particular word? सर बता पाएंगे क्या आप कौन सा वर्ड है? नो, फ्लेक्सिबल नहीं सर. ओके, फ्लेक्सिबल रहेगा तो थोड़ा सा प्रॉब्लम आएगा. सी, आई वांट to design the vehicle such that I should feel as a passenger that it should be a moving sofa, as if you are sitting on the sofa in your drawing room. So that is the ultimate, you can say, the aim of designing the suspension system. Is that fine? So sofa which is there in your drawing room, that is the most comfortable thing for sitting. Do you agree with this or not? अरे agree करते हो कि नहीं? हाँ, so you want that the suspension system should be like your the vehicle ride should be like you are sitting on a moving sofa. That's it. So this is basically why I have used this particular phrase, because in company, if you ask the designer, then they will say that I want to design the suspension of this system such that the passenger should get a feel that they are sitting on a moving sofa. That's it. That is the ultimate suspension system, if you could able to achieve that. So that is why you will find that most of the advertisement, they keep a coffee mug, or you can say a cold drink bottle on the armrest between the two seats, and then they show that you drive the vehicle on a rough road and nothing is happening to that particular cold drink glass or cold drink bottle or a coffee mug. Okay, so that is basically to make the impression that our suspension system is such that you won't know the quality of the road. So the functions of the suspension system, the suspension system must supply steering control for the driver under all road conditions, because they are together. If the vehicle is having lot many vibrations, then the driver may get fatigued, he may lose the control. Vehicle owners expect the suspension system to provide a comfortable ride. The suspension together with the frame must maintain proper vehicle tracking and directional stability. See, everywhere if you see that, here the directional stability word is going to be the important, because it should not happen that if you are driving the vehicle on a rough road and there are some potholes on the road, then your sitting position should not get tilted too much. Otherwise, then you will have some fear in mind. Okay, so fear of toppling the vehicle. So that fear should not be created with the use of the suspension system. The another important purpose of suspension system is to provide proper wheel alignment and minimize the tire wear. As you people are already aware what is wheel alignment, it is basically the positioning of the front wheels on the vehicle so that there should not be any other problem of directional stability, tire wear. And now the suspension system is also coming into picture to play some kind of role in that. The impact of front tires striking road irregularities must be absorbed and dissipated by the front suspension system. These impacts are distributed throughout the suspension, and this action isolate the vehicle passengers from the road shock. Okay, so in short, it says that road irregularities should not be reached to the passenger. The vehicle's ride characteristics are determined by the amount of impact energy that the suspension system can absorb. This is what I was trying to convince you, that what you achieve by reducing the amplitude, it is basically the impact energy that the suspension should able to absorb by the rate at which the suspension dissipates these tire impacts. Okay, so the impact energy that has to be absorbed, see, impact energy is continuous. So sir, what is the logic of designing the suspension system? Sir, I will tell you one practical exercise of designing the suspension system. So that is, this will give you the idea about how the suspension systems are designed in reality. एक मिनट सर, मैं थोड़ा सा अभी इस पे शिफ्ट होता हूँ ब्लैक बोर्ड पे, एंड आई विल एक्सप्लेन यू दी थिंग्स इन डिटेल, दैट हाउ द सस्पेंशन सिस्टम्स दे आर okay. So the data collection for the design of suspension system. Please understand that whatever I am discussing this is not available in any of the book. Usually you will see that the suspension system will require road load data. So what do you mean by this road load data? Now let us understand that this is these are the wheels of the vehicle. So let us say that this is the vehicle, here it is the driver driving the. Now suppose this is road surface. सर जब ये व्हीकल अभी ड्राइव करेगा सर, ये तो प्लीज अंडरस्टैंड दैट. So when you drive the vehicle on this particular road, then you are going to have these kinds of vibrations which will be faced by the suspension system. Yes or no? No, sir. Okay, chalo, ठीक है. So now you have the arrangement. You need to make the arrangement over here. There is some instrumentation which is kept into the vehicle. So these are instruments which are kept into the vehicle, and there are certain small displacement center or the accelerometer which are fitted to the vehicle hub. Now what is going to happen, as this vehicle is moving on this particular road, let us say that the vehicle has come to this particular at this particular junction, then the certain inputs are taken from the road in terms of the displacement. That means what you are trying to do, there is a certain inputs which are taken in terms of displacement, velocity, and acceleration. Okay. So you get certain data patterns. So data patterns are recorded. Suppose you record this and you get certain kind of data, let us say. So you collect it for, let us say, rough road. You collect all velocity, acceleration, and displacement. Then some data you collect it for smooth road, and likewise you collect the data for, this is velocity, acceleration, and displacement. Likewise you collect the data for the highway, then you collect the data for urban roads, depending on the type of the suspension system you want to design. Means the type of the vehicle, basically the vehicle is going to be the city vehicle, or it is going to be the off-road vehicle, whether it is goods carrying vehicle or it is the passenger carrying vehicle. So depending on that you collect these data patterns. Okay. And now what you do, you design suspension system for filtered road inputs. That means you apply some filters to do the data analysis and get the unwanted signals to be ruled out or to be cancelled from these particular signals, and then design the suspension system. So this is basically done based on, see, this is the vehicle which is of the previously designed similar category kind of vehicle in the company, and then they collect this particular kind of data whenever they wanted to design the suspension system for the new vehicle. Now you are ready with the data, you apply some data filters, you apply some mathematical tools to this particular data to filter out the unwanted noise, and then you come out with the actual road condition, that if you drive the vehicle in this particular condition, see, please note that this data will be related to your speed of the vehicle also. So this is the speed of vehicle. So at a different speed in different gears, you design the you take or generate this kind of data. Now imagine the exercise which is to be done for collecting such kind of data. It is going to be the huge data, and you need to first figure out that which kind of vehicle you want to launch or which kind of vehicle you want to design, and the intended use of the vehicle and the geographical area where you are going to use that vehicle. Okay. So please understand that this is a very huge exercise. The company will do this exercise and they have their own data bank wherein they will be having such kind of data available. It is not that the vehicle suspension system is designed very arbitrarily. So please try to understand. Okay, it is not that simple task that you design the spring, then design the joints, and then the vehicle suspension system is done. No, you have to take this kind of data for dynamic loading on the vehicle, and then you apply your mathematical equations and then go on, you can say, iterating, and then arrive at the final suspension system. So whatever suspension system calculations which we will be doing, they will not be directly applicable, but they are very close to it. Okay, so because we are going to have the lab on this particular topic, so I am explaining you the background of this. Now you have got the huge data, you filter out this particular data, you calculate what is, you find out what is the maximum dynamic load. So maximum dynamic load, and at that dynamic load on vehicle, and at that particular dynamic load, you need to design the suspension system. Only designing will not serve the purpose. You have to then, once the system is designed, the suspension system is designed, the suspension system is designed, then it has to be tested for fatigue. See, there is very interesting thing that we say that there is testing which is done. So testing now you cannot do alone only for the suspension system. Yeah, you can do it alone for the suspension system, provided you have the different components in the suspension system. For example, you have got the spring, you have got the suspension arms, then there are certain linkages which have to be used, there are certain joints which are to be used in the suspension system of the vehicle. All these components, they are individually tested for the fatigue life cycle, and usually the fatigue life, that every component of vehicle should have fatigue life of 10 raised to power 5 cycles. Okay, so this is basically the minimum requirement of the each component of the vehicle, that is it should survive for 10 raised to power 5 cycles. And now you are ready with the complete vehicle, wherein you have done the fatigue testing of all the components which are supporting the fatigue load. And after that, you assemble the complete vehicle, and now you test the complete vehicle for the fatigue. And there you will be surprised that the results will be different. And there you have to use this particular road load data. So nowadays, please understand that nowadays most of the vehicles or most of the vehicle manufacturer, they test the vehicle for the complete fatigue test, though it is not mandatory by law. See, there are certain testings which are mandatory by law. There are certain testings which are voluntary, that means or optional. So this fatigue testing of the vehicle is optional, but nowadays, so most of the automobile companies, they are very, you can say, there are a lot of design constraint, because if you over design the system, you are unnecessarily increasing the cost of the vehicle, and unnecessarily you are wasting more amount of fuel, because if the vehicle weight is more, naturally the force required to propel the vehicle in the forward direction will be more, and if that is more, then you need to burn more amount of fuel, then the engine capacity, you will feel that the vehicle is underpowered. Okay, so these are things, they are interrelated. The second aspect is, the moment you change the vehicle weight, the gross vehicle weight changes, then it may be possible that the vehicle category may change itself. Okay, so that is why you have to design, the design constraints are very, you can say, tight, and one has to take care of this. So this is basically the brief background of the vehicle suspension system. Anybody wants to ask any questions? Sir, please ask if you have any question. Otherwise, we will move ahead. सर किसी को कुछ क्वेश्चन है क्या? आप पूछिए, अगर नहीं है तो आगे बढ़ते हैं सर। से यस और नो। आर यू पीपल देयर और नॉट? ओके, so now the major components of the suspension system. Major components of suspension system. So naturally the suspension system will consist of the springs. One is the coil spring, the other is the leaf spring, then second you can say suspension system configuration, the rigid axle or independent suspension system, then the third one is the shock absorbers, or you can say dampers. So we will be looking at these components, then rigid axle, then independent suspension system, then spring and leaf spring. So designing of these particular components we are going to study. Now what is the factors? Now let us first discuss the factors governing the choice of the spring. So here in this series we are going to discuss the here we are going to discuss regarding the springs. So in that, now you know that the springs can be, I will write down different types of spring, then leaf spring, second one is coil spring, then torsion bar, then rubber spring, then air or gas springs. Have you studied any of these? सर ये आपने पढ़े हैं क्या स्प्रिंग्स? तो सर सोचिएगा, there are different types of springs and you have studied. We will be focusing on the leaf spring and the coil spring. Torsion bar little bit, rubber spring almost. These springs we will not study. These are basically, I will explain you when we will discuss regarding the complete configuration. Now the factors governing choice of the spring. Factors governing choice of spring. So the first one is the total weight of suspension system. Total weight of suspension system. Then the second will be total cost of installation. Total cost of installation. The third will be relative capacity of energy storage. Relative capacity of energy storage. Then fourth one will be guide linkage required. Guide linkage required. And the fifth will be the location of spring, where exactly you want to feed the spring in the vehicle. And the sixth one is fatigue life. So these are basically the factors which will govern as to which kind of spring you are going to choose, because please understand that leaf springs, they are used for certain types of the suspension system, and coil springs, they are used mostly for independent suspension system. Usually these are used for rigid axle suspension system. Okay, so and these torsion bars, they will be giving some kind of strength to counterbalance some of the force or some of the couples which are created due to the dynamic forces which are acting on the vehicle because of the road irregularities, because of the wind loads, because of the cornering forces. So likewise, you have to you take the intelligent decision for using the torsion bars. So this is basically the idea regarding the designing of the suspension system. So anybody is having any issue or any difficulty, please ask. सर किसी को कुछ डाउट है क्या सस्पेंशन सिस्टम के बारे में जो भी हमने आज डिस्कस किया? सर प्लीज से yes or no. Okay. So today we will stop here. Just wait. मैं जब तक कि आपको बोलता नहीं हूं जाने के लिए तो आप मत जाइएगा. एक मिनट. Sir, I have not checked your paper. I'll check the paper in a day or two because I was busy with some other activity. Tomorrow, what is the class timing, Shravya?
Sir, tomorrow we are not having any class.
Tomorrow we don't have any class. Wednesday at what time?
9 to 10, sir.
Okay, Wednesday 9 to 10. Okay, okay. Tomorrow we don't have class.
Yes, sir.
Okay. Why I am asking, because I forgot the timetable. So I haven't seen the timetable. So we'll meet on Wednesday. थोड़ा सा सर सब्र करिए, पेपर चेकिंग के लिए मुझे थोड़ा सा समय दीजिए. मैं आपको पेपर चेक करके मार्क्स आपको बता दूंगा, ठीक है? सो ओवर फ्रॉम माय साइड वी विल मीट ऑन वेडनेसडे 9 to 10. Yeah, okay. Thank you. Over from my side, if you have any questions, please do ask. When you people are planning to come to the college? आपको 21st को बोला है ना?
Yes, sir.
So how many people are interested to come to the institute? अरे कोई नहीं है. क्या हुआ? रोहित, हर्षिनी, प्रणव, श्रीनिधि, श्रीवास्तव, सर्वेश, आदित्य, प्रणय. अरे चलो, इंटरेस्टेड है काफी लोग. अच्छा, श्राव्या इज इंटरेस्टेड ऑन 21st. हर्षिनी, ओके 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 ओके. लेट्स सी कि क्या कर सकते हैं, तो ठीक है. चलो. सो सर थोड़ा सा पेपर के लिए थोड़ा सब्र करिए. मैं आपको पेपर चेक करके दूंगा. कल तक के मैंने फ्लूइड मैकेनिक्स के पेपर चेक किए, बिकॉज आई हैव गॉट 115 स्टूडेंट्स फॉर फ्लूइड मैकेनिक्स, सो इट टुक टाइम. तो आपके भी मैं पेपर चेक कर दूंगा. Over from my side, thank you for your patience because there was some issue with my PC. So now you can leave the meeting.